Hello, the following is a video tutorial for the Simple and Compound Gear Train lab with Onshape. The first step, as always, is to sign in to the Glenbrook Enterprise. Once you've done that, if you flip over to the Documents tab, locate your team folder for your class, and in there you'll see a new project folder titled Simple and Compound Gear Train Lab. Open that up. Select the file, right-click, go to Copy Workspace, remove Copy at the end of that title, and please add your first and last name at the beginning. As that's taking a moment to populate, I just wanted to flip over to the second tab that I have open here and show you the completed version of this lab. So this is what we're going for the simple gear train. We're going to have 4 different axle shafts. Each gear is on its own shaft, and you're going to link up the 36 tooth to the 12, from the 12 to the 60, and then from the 60 tooth to the 84 tooth. We'll do some gear analysis relations, so there are specific values that we'll type in to make it all animate and look nice. And when it's all said and done, you'll be able to animate the revolute constraint. I'll set this to loop. If I hit play, you can see each one of those gears individually rotating, and the gear relation values that we type in specifically allow this animation to look as good as it is. And they all rotate at the same speed, or the appropriate speed, I should say. So that's just a quick look at the simple gear train. The compound gear train will have 3 axle shafts. Starting on the first axle shaft, we're going to hook up the 84 tooth gear to the 36 tooth gear. That one will then share a shaft with the 60 tooth gear right underneath there, and then we'll make a connection from the 60 tooth to the 12 tooth gear to round it out. There are 2 drawing sheets for this activity. The first one is for the simple gear train. I dimensioned the diameter for each one of these gears. So using the diameter, tell me what's the diameter for the output gear, what's the diameter for the input gear, and then using those diameters, what is the gear ratio for the simple gear train? Make sure you show the formula and all your work using the note feature right here. On the second drawing sheet, you'll see the compound gear train. And this time around, I decided to give you the information relating to the number of teeth. So using the number of teeth, tell me what does the final output gear have in terms of teeth? What does the initial input gear have? But make sure that you take into account that this is a compound gear train, and we can't just go from first to last with this. So you will have to set up the formula and calculate what is the gear ratio for that compound gear train. As a reminder, you still do your out over in for the gears that are meshed together. And then when you have them on a single shaft, you want to multiply those 2 ratios together to get a total ratio for the entire gear train in itself. So I'm going to leave this tab open in case I need to come back and reference any of these dimensions. Pretty straightforward though. We're just going to set one of the bearing flats in there, and based on the spacing here, set up our gears on the axle shafts and then get them to rotate nicely together. Just going to be a little bit of offsetting with the heights for the gears so that they're in line with each other. And that's pretty much it. So let's go ahead and get started. Flip back over to this tab. Okay, and it loaded me onto the axles tab, but you guys should know at this point now, go ahead and move all the way down to the left and find the simple gear train assembly file. And I'll go ahead and set my bearing flats in place first. So just going back and forth here between my completed version and the one that I'm demoing for you, I'm going to skip 2 holes and put my first one, skip another hole and put my second one, skip 2 more, put the third, and then skip 5 and put the fourth. So let's go ahead and do that. I'm going to grab my fastened mate constraint, rotate to the bottom half of the bearing flat, get my edges to pop up, and go ahead and select the center hole. And it really doesn't matter where you start on here. I'm just going to start exactly where I had it on my completed version. So in the center of the plate, right on top of it, check mark to finish the placement. Do the next one, get the center bottom of that hole. We're going to skip one row and put it right there. We'll then skip two more and put our third one. Grab that point right underneath in the center. Skip two rows. Here comes our third bearing flat. And lastly, number 4, grab the center point on the bottom. We're going to skip 5 rows. 1, 2, 3, 4, 5. I'm going to put it right here on the 6th one. Double check that. Looking good. Okay. So next I can go ahead and drop my axle shaft in. And I do want this to be a revolute mate. So I'll grab the revolute mate here, rotate to the bottom. Go ahead and grab this bottom point on the center of the shaft. And then from underneath the plate, actually, I'll just go ahead and find that hole that I have my center point lined up on. And I'm just going to grab the very bottom of that plate. No offsets required. I did have an offset on my completed version, but it's not really necessary. So go ahead and continue that process. Grab the center point on the bottom of the shaft. Grab the center point on the bottom of the metal plate. I'll just do it backwards this time. I'll grab the center point on the plate and then on the axle shaft. And the last one, bottom center there, bottom center here. Okay, check mark to finish that placement. We now have revolute constraints for each one of those gears, or sorry, for each one of the axle shafts. We now have a revolute constraint for each one of the axle shafts. And the next step will be to go ahead and seat the gears onto each one of the shafts. We'll just have to do some offsetting so that the gears are nicely in line with each other. So we'll go ahead and start us off with a fastened mate. I'm going to grab the center top right here, grab the center top there, and I'm going to offset it in the Z direction, negative 0.5. Moving on to the 12-tooth gear, grab that top center point, grab that top center point, offset, Z, negative 0.5. That looks perfect. Check mark. Next, the 60-tooth gear, grab the center point on the gear, center point on the top of the axle shaft, do an offset in the Z direction of negative 0.5. Those are all perfect. And I believe the last one's going to be a little different just because of the extension that's on this gear. It's extended on one side and it's flat on the other. Either way, we'll have to do a different value for offset because these have a smaller offset around the axle shaft. So we'll go ahead and grab the top center point on this one, grab it here on the axle shaft. I'm just going to click on the right side of my view cube so I can see it from the right profile. That way I can play with this number for a moment. If we do point negative 5, ends up a little low, so we can bring that up to negative 0.3, which for all intents and purposes would be just fine. I'm going to add a little bit to that, negative 0.3125, and it looks pretty nicely in line right now. Hit the check mark to finish the placement there. And if you notice, you click on your gears, you can actually rotate them, but they're all glitching through each other. So the next step is going to be to set up that gear relation between each one of these gears. So the first one is going to be gear relation. And for mates, you can actually select, it might be a little easier just to grab it off the feature list here because you need to select certain mates. So I'm going to say between Revolute 1 and Revolute number 2, I want that relation ratio to be 3 because it's 36 out. I want that relation ratio to be 3, which is kind of counterintuitive to the formula that we use. We normally think about gear ratios as out over in, but for some reason when you're doing the relations here in Onshape, it's actually the inverse of that. So instead of doing 12 divided by 36 to get 3, I'm going to flip those numbers and say 36 divided by 12, which gives me the relation ratio of 3. Right? Now that should be pretty good in terms of rotation. They'll rotate in unison with each other. So you might notice that I do have a little bit of an overlap here between the gears, and the kind of cheap and dirty way to fix that is to slightly offset the rotation for the gear and the axle shaft. So if I go to my fasten mate number 5, I can hit the drop down menu here and say rotate around the Z axis. And if I just put a really small number in, and I'm going to click inside the box here just to see how far it moves, still a little bit of glitch with 1 degree. Try like 1.5 degrees. Still a little bit of glitch. Let's see how 2 looks. A little far on the other side. So 1.75. And you can really play with that as much as you need to in order to create the outcome that you desire. It's a little bit touching there still, so me being a perfectionist at times, I want to keep playing with that number and see where I can get it to line up nicely. Is it 6.5? That looks just about right. I could have just referenced the value on my completed version because I did take the time to go through and make those changes. But here, a rotation angle of 1.65 degrees allows those teeth to kind of line up nicely. I called it cheap and dirty because technically now, if you look here, we've actually rotated the shaft away from the center point, or like in alignment with the opening for the gear. So you do have a little bit of a glitch here, but it's such a small number that you're really not going to see it. And it's a fine trade-off here when you see those gears meshed perfectly and rotating perfectly with each other. So that would be my suggestion for you all as you're making your progress through this lab. Next gear relation, we're going from the 12 tooth to the 60 tooth. So I'm going to grab Revolute 2 to Revolute 3. My special number for this is 0.2. Hit the check mark to finish the gear relation. If I try to move this, getting a little glitchy just because of the lag here, but I'm going to go ahead and just animate it this way. Put it on a loop, 360 steps for 360 degrees. Play that. Always looks a lot nicer when you do it this way. So something we noticed, or something that I'm noticing right now, is my gear is actually rotating in the wrong direction. And you can change that by going to that gear analysis or the gear relation and just checking the box there for reverse direction. So go ahead and do that now. Double click gear 2 relation, hit the reverse direction option. Go back to Revolute 1 and animate it. See how that looks. That's better. Now the gears are rotating in the proper direction. Just might want to do another little offset here on the third gear to get those teeth to line up a little better. So let's go ahead and try that. Fastened mate number 7 is the one that I want to change. Rotate around the Z-axis is the direction we want to rotate in. If I just switch to the top-down view here, let's play with those numbers and see where we land. 1 degree looks perfect to me. There's a perfect amount of separation on each side there. So I'm going to go ahead and check mark that. And then run it one more time through the animate feature just to see how it all looks. Perfect. Very satisfying to see those gears turning in unison without any glitching between them. All right, we got one more to go. Do a gear relation between Revolute 3 and Revolute 4. My special number for this one is 0.714. Check mark. And then we can do a little offset here on our last constraint to get those teeth to line up nicely. So fastened 8 is the one that I want to mess with. Rotate around the Z. Let's try 1 degree and see where that puts us. I doubt it will work as nicely as it did last time. Okay, so 1, let's try 2. 2 is too far, split the difference, 1.5. A little much, 1.4. About 1.3. That looks perfect. Check mark. Finish it. Let's animate it and check the directions. Animate. Play it. And so in fact, my last one also needs to be reversed. It's rotating in the wrong direction. So on gear 3, reverse direction. There we go. Play it again, just to make sure. And there you have it. All 4 gears rotating in perfect unison with each other. The last 2 bits that we want to add here are going to be our gear ratio input and output indicators. Before we used red and green with our Simple Machine Labs to indicate forces. In this lab, I switched the colors purposely to go from blue to orange to signify input for the gear and output for the gear. To constrain our input and output arrows, I will grab the tip right here, and off the side of the bearing flat, there's a nice center point we can click on. I'm just going to flip it and then offset it a little bit so it's not hanging out on the bottom, glitching through the metal plate. So we'll do Z 1 inch, bring it back, and in the X direction, I can go up 1 inch, -1, just to bring it out and set it out in front there. All right, and then for output, grab that same point right there on the bearing flat, and I'm just going to grab the bottom of the cylinder on my output arrow and do a little offsetting. 1 inch for the Z. Like it wants to be negative, positive. There we go. Actually, it's glitching through the gear just a smidge, so I'm going to go -1.5. Just to push it out in front. And there you have it, the finished simple gear train assembly. Okay, so now I want you to take those same principles that I just walked you through, setting up the shafts, the bearing flats, and all that, and we're going to make our own compound gear train assembly. So let me reference my finished version. Compound gear train assembly, just for the spacing. I'm going to start off on the 6th hole and then skip 4 between the next axle shaft and then skip 2 between the 3rd axle shaft. So 5, 4, and 2. Let's go ahead and set those up. Fastened mate, top of the plate, 1, 2, 3, 4, 5. I'll go for the 6th one here. Grab that point. Bottom of the bearing flat. Grab the point on the cylinder hole. Check mark to finish. We're going to skip 4 spaces here. For the next bearing flat, grab that point. Skip 1, 2, 3, 4. Place. And then skip 2. Right there, grab that point. And then grab the bottom of the bearing flat. There we go. Okay, we got that in position now. And just like we did on the simple gear train, we'll get the axle shafts set in there using revolute constraints. Revolute. We'll grab the bottom of one of my shafts. And then the bottom of the metal plate down here underneath where the bearing flat is. Check mark. Finish that placement. We'll do another one, revolute. Grab that point on the metal plate. Grab the bottom on the axle shaft. Check mark to place it. Third revolute. Grab the point on the metal plate and then the point on the shaft. Okay, so at this point, we have all 3 shafts put in place. And now we're going to set the 84 tooth gear onto the first axle shaft. And again, we'll just have to play the game of offsetting that with the height to get the gears to line up and mesh well with each other. So I'm going to drop the 84 tooth in there with a fastened mate. And then I will offset that in the Z direction, negative 0.5. I might have to come back and change that number. I forget what my special numbers were that worked out well for alignment. On the next one, we're going to put the 60 tooth gear on the bottom and then the 36 tooth gear on top. Just going to double click number 4 here and change that to 1/4. And then we'll go ahead and grab the 36er, set that on the second axle shaft, offset it. I'm going to go with negative 0.175. Then I'll grab my 60 tooth. We're going to put this one on. Offset, -1. Bring that down. There we go, looks good. And then the last one, our 12 tooth, fastened mate. Grab the center point. Grab the center point on the axle. Offset in the Z direction, -1. Perfect. So at this point, what we want to do is add the gear relations. So I'm going to get started by selecting Revolute 2 and then Revolute 1. And my ratio for this is going to be 0.429. The check mark for reverse direction. Let's go ahead and check that. Run the animation through Revolute 1. That is now rotating in the correct direction at the correct pace. We'll just do a little offset there to make the gears look better and have them mesh better. The second gear relation that we want to set up is going to be from Revolute 3 to Revolute 2. And my relation ratio should be 0.2. Check mark. Let's go ahead and animate that. Perfect. So you can see with this transition that we've created of big gear to small gear and then big gear to small gear again, we've increased the speed output of our gear train. So let's go ahead and clean this up a little bit. We just want to do some offsetting. So I'm going to open up fasten mate number 4 and rotate around the Z axis. I'll hit the top view on my view cube so I can zoom in and see it from here. Let's do 1.5, a little much. 1.4, ooh, going the wrong way. 1 degree, 2 degrees, let's see, 2.1. Zoom in, 2.1 looks perfect. And again, you can kind of see here how those two profiles aren't really matching up now. So that's how we're cheating it a little bit here, virtually speaking, to get the teeth to match up nicely. And then I'll just do that again on my 3rd gear. So on fastened mate number 7, view it from the top down. We'll zoom in, rotate around the Z axis. Let's try 1 degree. -25 degrees. That's a big one. That's a lot of rotation. I think I could do better if I just go negative. Let's see here. If I go -5, that actually drops it in the exact same location, and then my shaft's not completely twisted out of control. That's fine. I'm going to go with -5 there. Hit the check mark. View it one more time to appreciate all the hard work we just put in on this one. Right click, animate it on Revolute 1. Want to loop it. 360 steps. Play. There we go. Again, very satisfying to watch those gears rotate in unison, especially this guy at the end here. Last 2 things on the assembly are to attach our input and output arrows. So I'm going to grab input here, just like we did on the simple gear train. Flip it, offset it, 1 inch back, -1 inch going up. That'll do. And then for output, grab the side of the bearing flat, grab the bottom part of the arrow, and we'll just do a little offset here. -1 and +1. There we go. Okay. Input and output indicators are in place. At this time, we can go ahead and switch it over to the drawing sheets. And as I explained at the beginning of the video, you'll answer these questions accordingly. For the simple gear train, use diameters. Please make sure you're using the note feature to actually type out your work. And on the compound gear train tab, you will use number of teeth to do these calculations down below. Again, use the note feature, type it out here on the sheet. Hopefully you enjoyed this tutorial, and I'll catch you next time.